So for cross product, this is red A cross B. Okay, so this is A cross B. Okay, this is the vector multiplication, which is cross product. Different than dot product. First of all, when we did dot product, we did magnitude of A times magnitude of B times cosine of the angle between them. And it did not have any direction. But for cross product, we do magnitude of A times magnitude of B times the sine of the angle between A and B, okay? And this n hat, John. Yeah, what is this n hat? This is a unit vector in the direction of the normal to both A and B, plane. Whoa, what does that mean? Well, when we have two vectors, A and B, it would create a plane. And the cross product is another vector that's formed that is perpendicular to both A and B. And that n hat means normal unit vector. Okay, so this n hat means normal unit vector. This word normal does not mean not strange. This normal is actually a mathematical term for perpendicular or orthogonal to, okay? So this normal means orthogonal to the plane made by vectors A and B. So they have to basically, A and B creates a plane, and this cross product vector have to be perpendicular to both A and perpendicular to B. All right? So when I cross A cross B, pretend that this is on a plane of my three-dimensional axis. When I cross these two, it creates a completely new vector that is orthogonal to my AB vector plane. So here is this is my A cross B vector. And this vector is perpendicular to both my A and my B vectors. So it's perpendicular to my A vector and it's perpendicular to my B vector. And to figure out the direction of this A cross B, now it could have gone this way or could have gone this way too, right? This can be perpendicular to both A and B, but which way does it have to go? To figure out that direction, you must use the right-hand rule. Now, everybody, please use the correct right hand. I know, people are like, wait, which one's the right hand? Oh yeah, this is L, so this is left, right? Use the right hand. I see so many students writing with the right hand and then use their left hand to do the right hand rule. And they get completely messed up. Okay? So please make sure you use the real right hand. So how do we do this? Well, I would place my fingers, right? Like for example, if I'm doing A cross B, and let's say this is on the XY plane, and the Z axis is coming straight at you like this. This is your Z axis. Whoa. You see that, Umar? Ready? Whoa, 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 whoa. It's coming at you. That's my positive Z. When I cross A cross B, I place my fingers along the A, which is the first vector, and place the hinge of your wrist at the common point, right? So place both vectors at the common point, place the hinge. I could only do it this way or this way. I cannot do it this way, all right? I have to do it either this way or this way. Because the hinge I have to basically curl my finger towards the second vector I'm crossing. So A cross B. Now notice the direction of my thumb is pointing up. So A cross B will create a vector that is pointing in the positive Z direction. Okay? So positive Z direction, so A cross B will create C vector that's going to be in the positive Z axis. Okay? Positive Z axis. When I do B cross A, B cross A, my thumb is actually pointing into the page, right? So B cross A would be then negative C vector or negative Z axis. Okay? You can represent the positive Z axis as dot with circle. This means out. Okay? And X with circle means in. And this is actual mathematical terms. And you'll also use that in physics too. Why is that? Well, if you see an arrow coming at you out of the page, you'll only see the arrow, tip of the arrow, right? Arrowhead. And you're going to see that like just the tip of it coming in like this. So it's dot with circle means out. When you see arrow going into the page, you would see like the feather and the knock, right? The feather, right? You'll see the feathers when you see going in. And that's what that means. And this is the convention they use in math and physics. Right? So out of the page, into the page. Okay? So all right? So that's the convention we will use. All right. Yeah, I don't think we're going to have time to finish this. So right hand rule is very important and is only good for bilateral symmetry creatures like humans. Other spherical creatures in like other galaxies can't use right hand rule because they don't have right hand. Yeah. This is only for humans or any other bilateral symmetry creatures. All right. All right. So if you ever think about orientation of your X, Y, Z, always think of it as the right hand rule as well. So here's your X, right? Your pointy finger is your X, right? Your, your bird finger, your middle finger, right, is your Y, right? If you ever have to flip somebody, use your Y axis. And then the Z axis is your thumb, okay? So you can actually, this is like the physics gangster symbol, right? Like, yo, as soon as you do this, they know you're a physics nerd. This is like physics gangster symbol, right? So if you ever get a tattoo, get this one first. Put X tattoo here, Y tattoo here, and Z tattoo on your thumb. So that's really hardcore physics gangster, right? And if anybody gives you that, you know what this is, right? If somebody gives you this, that means you're a loser. Yeah. You know how you up that? You give them this back. You're a three-dimensional loser. You're a loser no matter how you look at it. Yeah. So now you can up that, right? All right. Anyway, we'll finish